Good morning everyone. This is Deepanshi from BSc Chemistry Honors second year. Today I am going to present a presentation of organic chemistry. The topic of today's presentation is amines. Amines, the species which are formed by the replacement of one or more hydrogen atom of alkane, cycloalkane, benzene, side chain of benzene by amino NH2 group or carbon atom of acyclic ring, aromatic ring by an atom. R CH3 gives plus NH2 minus H give R C NH2 H H. There are some other examples. The species which are formed by the replacement of one or more hydrogen atom of ammonia NH3 by alkyl, cycloalkyl, aryl group or side chain of aryl group, and an atom may be or may not be a part of a ring chain called amines. Classification of amines. First is aliphatic alkyl amine, the compound which are formed by the replacement of one or more hydrogen atom of ammonia by the alkyl group are called aliphatic amines or acyclic amines. Cyclic amines, the compound which are formed by the replacement of one or more hydrogen atom of ammonia by a cyclic group are called cyclic amines. Aryl amines, the a compound which are formed by the replacement of one or more hydrogen atom of ammonia NH3 by side chain of aryl group are called alkyl amines. Type of cyclic amines. There are mainly two types: homocyclic amines, heterocyclic amines. Now, homocyclic amines. Homocyclic amine, the compound which are formed by the replacement of one or more hydrogen atom of ammonia by cycloalkene, benzene, side chain of benzene are called homocyclic amines. Now, heterocyclic amine, the compound which are formed by the replacement of two or more hydrogen atom of ammonia by acyclic group and nitrogen atom became the part of ring. A aryl group and an atom became the part of ring are called heterocyclic. Now, homocyclic is also further divided. Here are some information. First is alicyclic amine, aromatic amine. Now, alicyclic amine or aromatic amine, the compound which are formed by the replacement of one or more hydrogen atom of ammonia by cycloalkene, that is benzene, a side chain of benzene, are called alicyclic amine or called aromatic amines. Type of heterocyclic amines. Alicyclic amine, aromatic amine, the compound which are formed by the replacement of two or more hydrogen atom of ammonia by acyclic group. An atom became the part of ring are called alicyclic. Aryl group and an atom became the part of the ring are called aromatic. Now, classification of amine. First is 1 degree amine, the compound in which an atom is linked with the carbon atom are called primary amine. The compound in which the nitro atom is linked with two carbon atom are called secondary amine. Tertiary amine. Tertiary amine, 3 degree amine, the compound in which the N atom is linked with the three carbon atom are called tertiary 3 degree amines. 4 degree quaternary amine, the compound in which the N atom is linked with 4 carbon atom are called quadrilateral 4 degree ammonium salt. Now, What is Zwitter on or dipole salt? Zwitter. The species which are overall neutral but contain the same number of positive और नेगेटिव चार्ज ग्रुप कॉल्ड ज्विटराइन। दे आर दी जो होती हैं ओवरऑल क्या होती है, न्यूट्रल होती हैं, बट क्या होता है, सेम नंबर होता है पॉजिटिव और नेगेटिव चार्ज का। इसके लिए एग्जांपल है अमीनो एसिड, जो ज्विटराइन की फॉर्म में एग्जिस्ट करता है। इसमें क्या होता है, जो अमीनो एसिड है H2N C2R और C डबल बॉन्ड OH, amino acid is the example of Zwitter. Now a question arise, जो पैरा अमीनो बेंजोइक एसिड है वो एग्जिस्ट करता है एक ज्विटराइन की तरह कैसे? Here we show a para amino benzene. When it is there the transfer of H positive ion and the charge of positive और नेगेटिव चार्ज जो है वो इक्वल हो जाता है। तो क्या इसकी फॉर्म में एग्जिस्ट करता है ज्विटर आयन की फॉर्म में। पैरा अमीनो सल्फोनिक एक्ट एज अ ज्विटर आयन। जो पैरा अमीनो सल्फोनिक एसिड है, इसमें क्या होता है, जो सल्फोनिक एसिड है वो ट्रांसफर होता है H पॉजिटिव आयंस का, जो पॉजिटिव और नेगेटिव चार्ज होते हैं वो सेम हो जाते हैं, किसकी तरह एग्जिस्ट करता है, एक ज्विटर आयन की तरह। नाउ स्ट्रक्चर ऑफ अमीन। Due to the presence of lone pair of electron on the essential N atom, the amines are pyramidal in shape. The configuration is N is equal to 1s2, 2s2, 2p3, 2s, 2px, 2py, 2pz, Hc3, NH2. Now nitrogen inversion. The rapid inconversion of one antimerous form into the another antimeric form due to the small energy difference 25 kJ is called nitrogen inversion. Here is the example given below. Now metaamine is not a achiral due to the presence of two same hydrogen atom on nitrogen. Metaamine is not resolvable due to the rapid nitrogen inversion here. जो now जो N-methylamine is chiral due to the presence of different group on the nitrogen. N-methylamine is not resolvable due to the rapid nitrogen inversion. Here, quaternary amino salt is resolvable due to the absence of lone pair, and as nitrogen atom there occur no nitrogen. There is a no nitrogen. Quaternary amino salt is chiral due to the presence of different group of nitrogen. Now first type of functional group is amine. Functional group NH2, representation NHH. Name of the functional group amine. Name of the functional group amine. Second prefix. Now principal chain में क्या होता है, वर्ड रूट होता है 1 डिग्री सफिक्स, 2 डिग्री सफिक्स, 1 डिग्री प्रीफिक्स, 2 डिग्री प्रीफिक्स, नोमेनक्लेचर होता है। Now numbering in heterocycle compound containing N as nitro atom and their type amine. 4 pyrrole. 4n plus 2 pi electron is equal to 6n plus electron, तो pyrrole. Second is furon, not amine. Thiophamine, not amine. Indole, pyridine, quinine, isoline. All heterocycle compound contain an atom as heteroatom are amines which may be 1, 2, 3 or in the form of 4 degree amino salt. Pyridinal 2 degree amine, piperidine, thyroid 4 not a amine. Now physical property. Nature of bonding between molecules. First, there are some conditions for hydrogen bonding. First is the presence of hydrogen atom. Second, hydrogen must attach with more electronegative element atom, that is FON, hydrogen bonding. First is association. Second is state of substance. Due to the presence of intermolecular hydrogen bonding between the amine molecule, they show molecular association in the form of associate molecule. They exist in liquid state and give fishy odor. Now third is viscosity. They have high than hydrocarbon alkyl halide ether of comparable molecular masses. Boiling point. More heat is required to break the strong hydrogen bond present between the amine molecules, so they have high boiling point. Then hydrocarbon and allyl ether of comfortable molecular mass. Fifth is solubility. Due to the presence of intermolar hydrogen bonding between the amine and H2O molecule, there is a solubility because of the presence of hydrogen bonding. किसके बीच में, अमाइन के बीच में और H2O मोलिक्यूल के बीच में जो हाइड्रोजन बॉन्डिंग है उसकी वजह से इसकी सोलिबिलिटी है. अब जो कंपैरिजन करते हैं हम एसोसिएशन का अमीन्स और अल्कोहल के बीच में. नाउ on moving from 1 degree amine to 1 degree alcohol, the extent of hydrogen bonding increase due to the high electronegativity of the oxygen atom in alcohol, then low electronegativity of nitrogen atom in amine. क्या होता है, जो जो ऑक्सीजन की एटम की जो बॉन्डिंग होती है, जो इलेक्ट्रोनेगेटिविटी है वो हाई होती है किसके केस में, अल्कोहल के केस में, और कम होती है अमीन के केस में. सो जो एक्सटेंट ऑफ एसोसिएशन है वो भी बढ़ेगा. तो अल्कोहल में क्या होगा, ज़्यादा होगा, अमीन में कम. सो देयर इज अ मोर एक्सटेंट ऑफ एसोसिएशन इन अल्कोहल देन कंपेरिजन टू अमीन. Solubility of amines. Now the matter is solubility. Due to the presence of intermolecular hydrogen bonding between the amine and water molecule, amine are soluble in water. Their solubility जो है water की, किसकी वजह से, mainly because of the presence of हाइड्रोजन बॉन्डिंग किसके बीच में, अमीन के बीच में और वाटर मॉलिक्यूल्स के बीच में. Now we are discussing about comparison of solubility among of aliphatic amine and aniline. Aniline, जो the non-polar hydrocarbon part is larger in aniline than aliphatic amine. तो ऐसा non-polar hydrocarbon part is more in aniline, so the solubility of aniline in water is less than the aliphatic amines. Comparison of solubility among of isomeric primary, secondary, tertiary amine. On moving from 1 degree amine to 2 degree amine and 3 degree amine, number of hydrogen atom decreases. So the extent of hydrogen atom between amines H2O also decreases, and no hydrogen bonding in between 3 degree amine and water. Therefore the solubility also decrease. 1 degree amine, then 2 degree, then 3 degree. Now there is a comparison of boiling point among isomeric primary, secondary and tertiary amine. Here is the structure of primary, secondary, tertiary. In primary, only one R group is present. In secondary, 2 R groups are present. Whereas in the tertiary, there are 3 R groups. On moving from 1 degree amines to 2 degree amine to 3 degree amine, number of hydrogen atom decreases. So the extent of hydrogen bonding between the amines also decreases. So no hydrogen bonding in between 3 degree amines. Hence the amount of heat required to separate amines molecule also decreases. Therefore the boiling point decreases. So high in 1 degree, then 2 degree, then 3 degree. जैसे हमने देखा कि जो 3 डिग्री अमीन है उसके अंदर 3 R ग्रुप प्रेजेंट है, हाइड्रोजन बॉन्ड है ही नहीं, तो उसमें क्या होगा, जो हाइड्रोजन बॉन्डिंग होगी बहुत कम होगी, बॉन्डिंग कम होगी तो इजी हो गया उसको तोड़ना, तो मेल्टिंग पॉइंट क्या हो गया, कम हो गया. Now, comparison of solubility among amines alcohol of comparable molecular mass. On moving from 1 degree amine to 1 degree alcohol, तो एक्सटेंट हाइड्रोजन बॉन्डिंग का वाटर मॉलिक्यूल के साथ वो क्या होगा, इंक्रीज होगा. क्यों? बिकॉज अल्कोहल हैज OH ग्रुप प्रेजेंट. Due to the high electronegativity of O atom in alcohol, then low electronegativity of nitrogen atom in amines. Therefore, the solubility also increases from 1 degree alcohol to 1 degree amines. Now, the comparison of boiling point among amines and alcohol of comparable molecular mass. Comparison of boiling point among amines and alcohol of comparable molecular masses. On moving from 1 degree amine to 1 degree alcohol, the extent of hydrogen bonding increase. Due to the high electronegativity of oxygen atom is alcohol, then low electronegativity of nitrogen atom in amines. Now, comparison of solubility among homologous series of amines. The homologous series. Homologous series. On moving along the homologous series of amines, the alkyl part increases, and this the extent of hydrogen bonding between amines and water molecule decrease. So the solubility also decreases. For example, in methenamine, there is a strong hydrogen bonding and the smaller alkyl part is added. But in case of butanamide, the hydrogen bonding is weak. Also, the large alkyl part is attached to it. Now, comparison of boiling point among homologous series of amines. On moving the homologous series of amine, the alkyl part increases. जो alkyl part हो increase हो जाता है, thus the extent of hydrogen bonding decrease. Hydrogen bonding decrease हो गई. Hence, amount of heat required to separate apart amines molecule also decrease. तो हीट रिक्वायर की गई है वो भी डिक्रीज होगी. सो बॉइलिंग पॉइंट ऑल्सो डिक्रीज. नाउ बॉइलिंग पॉइंट क्या हो गया हमारा, डिक्रीज हो गया है. The methenamide है more, there is a strong hydrogen bonding, smaller alkyl part, so more heat is required. But in case of a butanamide, जो hydrogen bonding है वो weak है, large alkyl particle है, तो less heat is required. Now is a comparison of solubility among orthonitroaniline and paranitroaniline. Due to the chelation, the orthonitroaniline cannot form hydrogen bonding with water molecule, while paranitroaniline can form hydrogen bonding with water molecules. So, the solubility of paranitroaniline in water is higher than orthonitroaniline. जो क्लेशन की वजह से जो ऑर्थोनाइट्रोएलिलीन है वो फॉर्म नहीं, हाइड्रोजन बॉन्डिंग फॉर्म नहीं करती मोटर मॉलिक्यूल के साथ, लेकिन पैरा में क्या होता है, हाइड्रोजन बॉन्डिंग होती है. तो पैरा एलिलीन क्या है, मोर सोल्यूबल है. Here is the structure of orthonitroaniline and paranitroaniline. Now, comparison of boiling point among orthonitroaniline and paranitroaniline. Due to the chelation in orthonitroaniline, there will be weak van der Waals bond in between orthonitroaniline molecule, but due to the absence of chelation, There is a hydrogen bonding in between para-nitroalanine molecule and thus more heat is required to separate apart para-nitroalanine molecule than orthonitroalanine molecule. So the boiling point of para-nitroalanine is higher than orthonitroalanine. ऑर्थोनाइट्रोलिन में क्या होता है, नो हाइड्रोजन बॉन्डिंग, सो नो हीट. पैरानाइट्रोलिन में हाइड्रोजन बॉन्डिंग होती है, मोर हीट इज रिक्वायर्ड. थैंक यू.